Now in this problem, we have this rod that's spinning around its center. Whoops, center here. With some, let's say that it's spinning this way. And it has some angular velocity that I'm going to call omega 1. They also tell you the mass of the rod and the length of the rod. And then it's going to change shape. So we know from conservation of angular momentum that I number 1, omega number 1 is going to be equal to I number 2, omega number 2. And we know omega 1, we're asked to find omega 2, so all we need are the two different moments of inertia. Well, if I look up on a table of moments of inertia, I can find out that the moment of inertia of a thin rod rotating around its center is 1/12 mass times the length squared. Now, if all the mass suddenly goes to the two ends with half of the mass on either end, then we'll have 1/2 m down here and 1/2 m down here, and basically nothing in the middle. So now what we have is two bunnies on a string going around. So each bunny on a string has a moment of inertia of mass times the radius squared, right? mr squared is the moment of inertia of a bunny on a string. So for this guy, the moment of inertia is going to be 1/2 m for the mass times the radius, which is from here to there, right? So that's the radius, which is half the length, and we square that. So this comes out to a total of 1/8 ml squared. And this one will be the same, 1/8 ml squared. So the total for moment of inertia number 2 is going to be 1/8 ml squared plus 1/8 ml squared, for a total of 1/4 ml squared. And we can put that all together. So I1 is 1/12 mass times the length squared times omega 1 is going to be equal to our 1/4 mass times the length squared omega 2. A whole bunch of stuff cancels out, namely the masses cancel out from both sides, length squared cancels out, so we can get the answer easily from there.